Hello class, this video is to review the frame, and we're using this example to recap some of the concepts we learned about frames. So as you can see, AB and BC are connected at B, and we need to find the moment reaction at point A. Okay, so at A looks like it's a fixed support, so FBD number 1, this entire structure, we would have at point A, AX, AY, we're also going to have a moment at A due to a fixed support. So we have MA. And for roller support at C, we only have a CY. Okay. So if you look at this entire FBD number 1, we will have 4 unknowns, and at most we can get 3 equations, so that we cannot solve every single 4 of them. So remember, at frames, we often have a strategy of looking at individual member at a time. So if we were looking at FBD number 2, looking at member BC, what do we have? We'll have this external loads 900 Newton. We also at C, we'll have the CY due to a roller support. Since B is a pin support, we will have BX and BY. Now, we only have 3 unknowns, right? BX, BY, and CY, so we can certainly solve that. Now let's go back to FBD number 1. If we were to use in this entire FBD 1, we will have 4 unknowns. If we can find a CY in the second FBD, then we will be able to solve the problem. So here, our goal is just trying to find CY. So how do we do so? Let's set up a moment equation. If we do moment about B, we have this 900 Newton times 3 for moment of arm, it's clockwise negative. Then we have CY times entire beam, that would be, oh, I made a mistake, isn't it? So 900, this is 1.2. So I'm gonna use this handy dandy eraser here. So that's going to be our 1.2. All right, so for CY, the moment of arm will be 3, and that is counterclockwise, so that's plus, that equals to 0. So from this calculation, do you get CY as 360? Okay, 360 Newton. Now, like we have brainstormed earlier, if we know CY, we can go back to our FBD number 1. So we see CY is actually a known number now. It's 360 Newton. And what we're trying to look for, it's moment reaction. Basically, they want you to find the moment at A. And they do not need you to find AX and AY, only MA. So in FBD number 1, how do we find MA in one equation? That's right, we're going to do sum of all the moments at A, okay, for this entire frame. Now let's first take a look at it. Let's go start at point A. At point A, AX and AY going through point A, so they do not show up. However, we have this MA itself due to the fixed support, so that's what we're solving. It's positive since it's counterclockwise. And now you have this distributed load along the beam AB. All right, quick recap on how do we solve distributed load. So this is the triangular area. So the concentrated load magnitude will be the area underneath the curve. So it'll be half times AB nonce times 4 times 1200 Newton per meter. That will give us 2400 Newton. So that's the concentrated load. If we were replace this distributed load with this one single load as 2400, where do we place it? That's right, it's going to be the centroid. So the centroid will be, for this triangle, is going to be 1/3 from the base, right? 1/3, so it's from the fatter end. So if this entire one is 4, so this is going to be around here, 2400, and it will be 1/3 of 4 from B, correct? 1/3 of 4 meter from B. Okay, so that's our location and the concentrated load magnitude. So now let's continue to work on our equation. So you have MA, and now distributed load, it's 2400. That's our equivalency. Then where is it located? 1/3 of 4th from B. But where are we rotating about? We're rotating about A. So it's going to be actually 2/3, right? 2/3 of 4 from A. And that is going to be rotating, clockwise rotation about A. So that's negative. Then we have moved to this 900 Newton. So this 900 Newton is going to be rotating about A. And the moment of arm is 1.2. And that is clockwise, so that's negative as well. Then the last force is it's CY, which we already know. It's 360 Newton. And that moment of arm is going to be 3. And that is counterclockwise, so that's plus. All of that going to give us equal to 0. Okay. So with all of this, and we can calculate our MA equals to. And based on what I have over here, my MA calculation given to me is 6,400 Newton meter. Okay, so that's all. That's to find the moment of reaction at A. So this is a quick recap on frames. Make sure for frames you can look at the entire structure or individual FBD itself. Okay, have a good one. Bye.